This is the third of our presentations on measurement. This one's based around area. Once again, a lot of the content in this presentation are things you've seen in grade 7 and 8, but we'll extend you with some new features as well. So this is our learning goal, using our knowledge of units of area and basic rules to calculate area and apply them across a variety of shapes and practical applications. So area of a closed shape is the amount of surface enclosed by the shape. So it's a flat, two-dimensional surface. It's measured in square units, which we've already talked about, and the other unit we haven't talked about is a hectare, which is 100 meters on one side, 100 meters on the other is 10,000 square meters. Now obviously it doesn't need to always be a square, but that's how we define the hectare. So these are formulas that you should already know. The square, the rectangle, the triangle, the circle, the parallelogram, and maybe the trapezium is new. Some of you will have seen it in grade 8. So we're going to look at these and explain how they're built. So every one of these basic formulas actually comes straight from one of the formulas. So everything's built from this one, the rectangle. So if we look at a triangle, for instance, a triangle is half a rectangle. So that's why it's base times height. Height and base. Let's just change that to a different thing. And then we halve it because it folds on top of itself like so. It doesn't matter what the shape is. This one here is actually two parts there folded on top to make the full rectangle. A square is just a special sort of rectangle where both sides, the length and the width, are the same. Parallelogram, let's look at that one. So with a parallelogram, because the sides are parallel, if we cut this piece off, and you can do this yourself, that piece fits in over here. And what do we have? We have a rectangle with a width of h, or height of that shape, and a length of b, hence the formula a equals bh. Now trapezium is sort of similar. It's a bit hard to see this one. If we cut it sort of halfway down those diagonal slopes, that piece folds up in here. And this piece, same idea, folds up in here. And what you end up with is a rectangle, like so, where the width is h, and these two sides here, the length, are actually the average of the top and bottom. That's what the a plus b over 2 is. Add two numbers together and average them by dividing by 2. So what we're essentially doing for trapezium is making a rectangle with the average length of the top and bottom parallel sides. Now the link at the bottom here walks you through that in a little bit more detail if you'd like to see that again. But one of the key things here is understanding that all the formulas we're given for area are all based around that idea of a rectangle. So if you know your formula for rectangle, you can often develop or think about how those formulas relate to the other shapes, the other quadrilateral shapes and triangles. Well, obviously the circle is a little different again, that's pi r squared. One of the areas of confusion that students have here is confusing it with circumference, which is 2 pi r. Both formulas have the same digits and letters. They both have a 2, they both have a pi, both have an r. The way to remember it is that area is squared, and the units of area are also squared. And that's one of the ways to help remember which goes where. Hopefully it's not too much of a concern for us right now. So let's move on. Let's look at some examples using these formulas. And like I said, most of these formulas should be familiar from grade 8. So area of a triangle. It doesn't matter that this is not a triangle like this or like this. It doesn't matter that it's hanging over. What we need to remember here is we need the perpendicular height there. So let's change our colour. So this is our perpendicular height. It's 40 centimeters. And the base is the piece that sits on the bottom. I could have, if I wanted, drawn that triangle like this. So rotated it around. And the measurements were given are 40 centimeters here and 88 centimeters along here. That side there. This is our 40 here. Now, once again, it's tricky for us to work with, but the orientation doesn't have to be the base. Base is just a nominal word we use. It doesn't mean that it's that side there. It doesn't mean it's sitting on the ground. So we can rotate our triangle whichever way we like. So we're going to find the area this time. Let's move on to the next page. There's our formula. We substitute in. Our base was 88. Our height was 40. Multiply them and divide by 2. Now there's a couple ways we can write that formula if you like. They all mean the same thing. Half base times height. Base times height divided by 2. And the one we're given there. Base times height over 2. They all mean the same thing. I don't mind which one you use when you write your formula. Let's just go back. Don't forget our units of area, units squared. Okay. So here's a composite shape, a little bit more challenging. The challenge here is to work out what shapes we have. So we've got this entire shape here. We've only got one measurement. First thing we need to do is recognize that those three things mean these sides are equal. What's not clearly indicated is that we have that attached there. Okay, so this mark goes up to this point, the straight end of the straight line. What we've got on top is a semicircle, so it's half a circle, which means that this here means that side has to be equal as well, because there's a right angle there and they're equal lengths. This is a square, so we've got the area of a square, shape 1, area of a semicircle, shape 2. Okay, and this side here indicates that the diameter is the same as this. It's 50 millimeters. So we calculate each of those. There's a diagram to show you how we've just broken that up. Calculate each of those. The total area is the area of the semicircle plus the area of the square. So let's work out the area of the semicircle, and you'll see how I've set this out. I've clearly labelled what I'm calculating at each point. So area of the semicircle, area of a circle is pi r squared, and we're halving that because it's half a circle. So radius is 25. If we go back, we'll see that. The diameter is all the way across, so d equals 50. So our radius is what we need to use, is half of that. So we substitute 25 in. Calculate that, we get 981.7, and it's millimeters square. The other shape was a square, and that's length squared or side squared. The side of the square is 50, it's not 25 like the radius. Be aware of what we're actually talking about. We square that, we get 2500 square millimeters, or 2500. So our total area, we add those two together. So that one there goes in there, that one there goes in there. We get a total of 3,481.7 square millimeters. Now they do get more complicated than that. That one's probably a low-level B question because of the number of steps or pieces involved. Now, as we did with sectors and perimeter, we're going to talk about sectors and area. Area is actually a bit easier. Same idea though. We've got a fraction of a circle. So we're basically taking that circle and cutting a piece out of it. Area of a circle equals pi r squared. We already know that. Area of a sector is a fraction of that circle. So the area of the sector equals the fraction times the area of the circle. Let's look at that on the next page. So here it is here. There's our fraction of a circle. It's the angle divided by the number of degrees in a circle. And we multiply that by the area of the circle, pi r squared. So sector is a fraction of a circle have 360 degrees. It's the angle that's important. So let's look at this question here. Unlike the perimeter of a sector, we don't really care about the two radii as such. We just care about the shape itself, or how much area it covers. So in this case, all we need is the radius and the angle. We write our rule. We know our angle is 30 degrees out of a total of 360. So it's actually 1/12 of a circle. And the area of the circle is pi times 5 squared. We work that out, we get 6.5 meters squared, or square meters. Okay, now it's over to you. Here's some questions for you to practice. Question 1 and 2 are working on area of basic shapes. Questions 4 through to 11. Mix it up a little bit. Now notice 8, 9 and 10 aren't in that list. They're moderately challenging, where they might have units to change or some other extra step. The challenge questions, where ideally we want you all to be, are ones with either word problems or multi-step questions. And for those of you who are really after a big challenge, question 19 is the one you want to look at. That concludes our presentation.